Hello everyone, welcome to my channel, and we have something new circuit here. What do we have here? We have here the power supply. This is my homemade power supply, 8 volts, 1 ampere. Also, we have the latch switch. We have the new circuit here. This is the latch switch. And we also have the load, the DC motor fan. Some cables lying around here. And let us take a seat. Okay. So in this video, we're going to make a switch to power on this DC motor DC motor fan, small DC motor fan, and instead of using an ordinary switch, a mechanical switch like this, or I'm going to use a push button. That will serve as just like the mechanical switch, using a regular push button. So I decided to construct a module using a 555 timer to convert the push button, which is a normally open switch, to a toggle switch or a latch switch, to convert the push button into a latch switch. So to convert that using a 555 timer, I constructed this module with a built-in onboard buzzer, output LED, and then the power LED, capacitor, some resistors, the header for the output, and for the power, also with the shunt diode for inductive load. And also I have the power transistor to have to accommodate large power output or voltage output. And this is now our module. We are converting the push button into a toggle switch, just like this one. This is the PCB, lots of jumpers, using a perf board. Okay, we have here our power supply. Let us turn on our power supply. This is a homemade power supply. I built this power supply because I don't have an adjustable power supply. So I built this power supply. Turn on the power supply. Okay. You can see here it has a minimum voltage of 1.2 volts. I have the power LED. Also I have the output LED, the blue one. You can see here that it seems like it's blinking, but with our naked eye it's not blinking. It's just the camera that is blinking. With our power supply, we have the binding post for the banana jack, positive, negative. Also I have the barrel jack, and then the USB port 2.0. I also constructed a banana plug with the alligator at the other end. Another one. And we're also going to use these jumper wires, or the patch wire, male to female. Also we have here 4 sets. And to our power supply, we can adjust it up to 22.5 volts. Did you see the output LED? When you decrease the volume, when you decrease the voltage, the LED blue is slowly turning off. That is our power supply we're going to use. Okay. Let us now see our load. We have here a DC motor fan. I bought this in Quiapo, Manila, Philippines. And the sales lady told me that it is 5 volts voltage rating. So let us check if it is 5 volts voltage rating. If it has a 5 volts voltage rating, let us check. So we're going to connect the banana plug. Okay. The other one. Okay. positive to positive, negative to negative. Did you see the fan is running with a voltage rating of 1.2 volts and current rating of 0.02 ampere. So it works on 1.2 volts with a current rating of 0.02 ampere. You can increase the speed up to 0.04 ampere. Okay, let us take a break. Let us continue our discussion. If this is 1.1 with the voltage of 1.2, 0.6 watts, because 2 volts times 0.03 ampere, or 2 volts multiplied by 0.03 ampere is equal to 0.6 watts. If we're going to continue adjusting the voltage, since this is adjustable voltage supply, we're going to destroy the motor fan or the motor. We don't have any resistor. That's why I think it's only capable of handling 0.4 ampere because the motor is running so fast. Let's adjust it to the minimum. For this procedure, we're going to check the stall current of the motor. Stall current when the motor is being stuck up. Let us see. It has 0.16 ampere current, stall current. I press the fan to stop. 0.16 ampere. That is the stall current of the motor. 0.16 ampere. So you can increase the speed by adjusting the voltage supply. Okay, so we're now going to use our module that will serve as the power switch to the DC motor. Let us connect the module. Okay, I now connected the power to the module, to the header, and to the power supply. Let us increase the voltage. You can see here LED turns on. The power LED is now turning on. See that? With 2 volts voltage rating. Okay, as you can see here, when I press the button, did you see that? We are consuming a current of 0.06 ampere. 0.06 ampere and 8.8 volts. So, or 60 milliampere. That is the power consumption of this module when we are pushing the button. Okay, let's continue. I also have constructed a latch switch made up of 2 transistors. This is my previous project. See it? Also, it has a buzzer and an output LED, and with a different type of a header. Let us connect this to our power supply to check the latching switch of these 2 transistor latch switch. I'm using 2 transistor to convert this push button into a latch switch. This is my previous project, and if you are interested, you can check the video description down below. Let us now connect the power supply. Positive to positive, negative, then to the negative. It's raining outside. Still, the switch is not working, so let us increase the voltage supply. Okay, increasing the voltage supply to around 1.8 volts, 2 volts, 2 volts. And the power LED turns on. This is a latch switch using 2 transistors. This is my previous project, and I'm using only a discrete components. It's an old circuit design, unlike the new one. So let us check if it is latching. When I press the button, it didn't latch. Okay, let us increase the voltage to 5 volts. 5 volts. You can see the LED is having a bright light. Press the button, so it is latching at 5 volts with what's this, 4.9 volts and 0.04 ampere. Oh, 40 milliampere. The LED is latching at 0.04 ampere, but the buzzer is not buzzing, or the buzzer is not yet working. So let us increase again to 7 volts. Okay, 7 volts. Again. We're not getting a stable circuit, stable output. Still, we're going to adjust the voltage supply up to 9 volts. We have here around or approximately 9 volts. At 9 volts, let us press again. Okay, let's continue. So it's latching around 8.8 volts, 0.1 ampere. Without latching, it uses 0.09 ampere with a voltage of 8.8 volts. With latching, so the circuit is consuming around 100 milliampere of current, whereas our 555 timer latch switch is just 60 milliampere. So the 555 timer is more efficient than this transistor latch switch, but this transistor latch switch is less expensive to build. Unlike this one, it is more expensive to build this type of module, but this is more efficient. It uses only 60 milliampere of current. Here it is using 100 milliampere, consuming a 100 milliampere of current times the voltage used, 8.8 volts. So it's 0.8 watts. 0.8 watt. This is 0.6. This is 0.8. Almost 1 watt. And it's raining outside. So let us now see how to connect the load to the 555 timer, and also if it is possible to connect to this transistor latch switch. Okay, we connected now the load, the DC motor fan, to the header of the 555 timer, and we're going to adjust the voltage at around did you see that? It's working. When I press the switch, fan is running. Press it again. You cannot see the output LED, and also you cannot hear the buzzer because it requires at least a current of 60 milliampere to sound the buzzer and to light the LED. While here, we just a voltage supply of 2.4, but still we're not getting a stable. Let us increase it again. You can see here around 1.1 volts, and without any latching, we have a small amount of current, where we're going to increase the voltage supply. Still again, we're not getting a nice latch. See it around 1.4 volts, and .02 ampere. We can latch the motor, DC motor. But we're not getting a stable circuit. .3 volts, 0.02 ampere. We could not get a stable circuit using a latch switch. See, it's automatically shutting down our latch switch. Automatic shutdown. That is the effect of using a latch switch to the DC motor fan. It is not advisable. Okay? We can construct another module to run the motor fan. Maybe the next time we can construct another module, because this latch switch cannot even run the fan. Automatic shutdown. We're having an automatic shutdown using a latch switch with the 555 timer. Even we have the power transistor here. Even with the use of power transistor at the output, we could not get a stable circuit, and we cannot use the DC motor for this transistor latch switch, because it has no output, or it has a low sourcing current. Okay, But this module, we can use this module to control this module. That is another feature of this project. Let us see. We can do that by connecting the transistor latch switch to the output of the 555 timer. We can see if it's working. How can we? Okay, we can do this one. We can connect it in here. This one is negative. One is positive. Okay, negative to positive, positive to positive, negative to negative. We're going to control the transistor latch switch using the 555 timer latch switch. Let us now increase the still. Okay. We have now the power LED. Let us press it. Still, we're not getting anything. Positive should be here. The positive. Oh, to positive. Did you see that? Increasing the. This is now the master switch to the transistor latch switch. Let us make it 9 volts. And you can turn on the power by pressing the button of the transistor latch switch. Once we power on the transistor latch switch. So this module can it will serve also as a power switch to the another circuit with this transistor latch switch. That is our 555 timer latch switch. We can now come to our circuit analysis using a circuit diagram of this new latch switch. Okay?